Real numbers. So far we have seen what are rational numbers. We have defined rational numbers as any number that can be expressed in the form of p by q, where both p, q are integers and q not equal to 0. We have learned that rational numbers include all of integers, and integers include all of whole numbers, and whole numbers include all of natural numbers. We have seen that rational number are numbers such as 2 over 3, minus 4 over 5, minus 1002 over 518. I'm just randomly writing some numbers. All I'm trying to do is I'm trying to write in the numerator, I'm trying to write an integer, and in the denominator I'm trying to write an integer which is not equal to 0. So all of these numbers are rational numbers, and there are infinitely many rational numbers. Now, what are irrational numbers? We have seen that irrational number is any number that cannot be expressed in the form of p by q, where p, q are integers and q not equal to 0. So any number that we cannot express in this form is irrational number or not a rational number. And what are such numbers? Some examples: square root 2, square root 3, square root 11, square root 15, square root 21, so on and so forth. These numbers, we cannot express them in the form of p by q, where both p, q are integers, q not equal to 0. And we have seen there are infinitely many such numbers. These numbers are called irrational numbers. So what happens if we take all rational numbers, there are infinite of them, and we add all of the irrational numbers to them? So this brand new collection, which includes all rational numbers plus all irrational numbers, we call this collection real numbers. So collection of all rational numbers, and all rational numbers we express them with uppercase letter Q, the collection. All irrational numbers. So the collection of all rational numbers and all irrational numbers, we call that collection real numbers, and we represent this with uppercase letter R. So if I were to tell you that A is a real number, so I just wanted to make sure that you do not automatically assume that A is a rational number, because A can be a rational number, but A can also be an irrational number. Because if A is a real number means it can be either a rational number or an irrational number. Real number is simply a collection of all of the rational numbers and all of the irrational numbers.